In this video, we're going to go over how to solve trig equations. So solving trig equations is very similar to solving other algebraic equations. The key is that instead of isolating the variable, you are going to need to isolate the trig function with the variable. So if you've got sine theta or cos theta or tan theta, your goal is to get that by itself. Once you have that by itself on one side, the other side is either going to be a special angle, and we can use exact values for that, or we can use a calculator. You also have to pay very close attention to what quadrant your angles will be located in and solve for those quadrants. So look for where values are positive or negative and solve accordingly. So if we look at the first example, it's asking you where sine theta is equal to 1/2. And it's asking you to solve first in degrees and also in radians. So this first one, sine is equal to 1/2. Sine is positive in quadrant 1 and quadrant 2. And 1/2 is a special value. So we can solve using our unit circle that theta will be equal to 30 and theta will be equal to 150 in degrees, or in radians, pi by 6 and 5 pi by 6. In question 2, it says that cos theta is equal to 0.3. You'll notice that this is not one of our special values from the unit circle, which means you're going to use a calculator. To solve in degrees, you're going to do the inverse of cosine. So cosine inverse using second function of 0.3. That is going to give you the angle in the first quadrant. So theta is equal to 72.5. But we know that cosine is also positive in quadrant 4. So to solve for quadrant 4, we know that if in quadrant 1 our angle is 72.5, then in quadrant 4 down here, we're going to do 360 minus 72.5 to get our angle. And when I do that, I get 287.5. Now, so far, you've only ever used your calculator in degrees. But if you're looking to solve for these values in radians, you're going to have to switch your calculator from degrees into radians. So you're going to look for your degree button or mode button, and you want to change it into radians. So here you should have rad or an R, something like that on your screen indicating that you're in radians. Once your calculator is set to radians, you're going to do the exact same steps. So cosine inverse of 0.3, but you'll see now the answer is given to you in radians. So 1.266. And again, if we know that this is 1.266 in radians, then we know to find down here, we're going to subtract 1.266, but instead of from 360, we're going to subtract it from 2 pi. And when we do that, 2 pi, make sure you use the pi button on your calculator. Don't round it to 3.14. And subtract 1.266, we get our second angle. So we have 2 solutions for theta. In example C, it says that tan theta is equal to √3. Now you may not know your tan values off the top of your head, but this is in fact a special value. Tan theta is positive in quadrant 1 and quadrant 3, and it's equal to √3 at 60 degrees, and then in quadrant 3 at 240 degrees. If we find those equivalent answers in radians, that's pi by 3 and 4 pi by 3. So you'll notice we need to solve for the angle and also consider what quadrants our solution should be in. If we look on the next page, this equation has a few more steps, but you can treat this equation just like you would treat an equation like 2x plus 1. So if you look here, we've got 2 sine theta plus 1 is equal to 0. And it's asking for the solution where theta is between 0 and 2 pi. This means we're going to look for solutions in the first revolution on the unit circle and also give our answer in radians. So the first thing we need to do is isolate the trig function. So here we have 2 sine theta plus 1, so we're going to subtract 1 from the other side, and then we're going to divide by 2. So sine theta is equal to negative 1/2. And that is a special value from our unit circle. So sine theta is equal to negative 1/2 in quadrant 3 and 4 at 7 pi by 6 and 11 pi by 6. In example 3, again, it's asking you to solve the following equations for theta, and again, we're using theta between 0 and 2 pi, so radians. Sine theta is equal to 0, well that's where y is equal to 0 on the unit circle, so it's 0 and 2 pi, as well as pi. Cos theta is equal to 0 at the 2 peaks of our unit circle, so pi by 2 and 3 pi by 2. Tan theta is equal to 0 at 0, pi, and 2 pi. Cosine is equal to 1, where theta is 0 and 2 pi, because remember, cosine is negative 1 when cos is negative, when cos is equal to, or when theta is equal to pi. Sine theta is equal to negative 1 at 3 pi by 2, and here cosine theta equals 3. This value should never be greater than 1. So here, if you have cosine theta or sine theta, these should be less than 1. So this is undefined. And finally, on the next page, we've got a couple multi-step equations. So the key with these, again, is isolate the trig function, determine what quadrants you're in, and then solve accordingly. So here, again, it's defined that we're solving for theta, where theta is between 0 and 2 pi. So we're using radians, and use exact solutions where possible. That means if it's on the unit circle, you are going to give those as exact values, and otherwise round to 3 decimal places. So if we look at the first question, we've got 2 cos theta plus 1 equals 0. So I can subtract 1 and then divide by 2. And I'm resulting with cosine theta is equal to negative 1/2, and that's on the unit circle. Cosine is negative in quadrant 2 and 3, so I have a solution of 2 pi by 3 and 4 pi by 3. In question B, it's a little bit more complex of a question. We've got tan theta on both sides. Remember, you can treat this in a very similar way to how you would treat something like 3x minus 5 equals 7x minus 6. Okay, so you can treat it very similar to that, in that we want to gather the like terms. So in this case, 3 tan theta and 7 tan theta, we just subtract 7 tan theta. So we're left with 4 tan theta. And here, we would add 5, so we're left with negative 1. So very similar to how you would treat this with just standard variables. And then when we divide by negative 4, we get that tan is equal to 1/4. Now that is not an exact value on the unit circle, so you're going to be using your calculator. So you're going to do tan inverse of 1/4. And important to note is that when you do this on your calculator, this is going to give you the answer in quadrant 1. So tan inverse of 1/4 gives us 0.245. And tan is positive in quadrant 1 and quadrant 3. So this is one of our answers. But then in quadrant 3, to find the related angle, we need to add this to pi. So pi plus 0.245 gives us our answer in quadrant 3 of 3.387 radians. In question C, we have a reciprocal function. Now here, when you isolate this variable, when you isolate the trig function, you get that cosecant theta is equal to -2 over root 3. But remember, when I take the reciprocal of that, it gives me sine theta, and it allows me to flip this value, which is an exact value on our unit circle. So here, sine theta is equal to -√3 over 2, when theta is equal to 4 pi by 3 and 5 pi by 3. And similar in question D, here 2 cotan theta is equal to 3. So if we first I've got an extra letter in there. If we first just isolate cotan, we get that cotan theta is 3 over 2. But then if you take the reciprocal, because you'll notice there's no cotan button on your calculator, if we take the reciprocal, we get that tan theta is 2 over 3. So again, to find the answer, we're going to use the inverse of tan of 2 pi by 3, which is 0.588. So in quadrant 1, it's 0.588, but then tan is also positive in quadrant 3. So we add our answer to pi, 3.730. So that's the first lesson on solving trig equations.